Hi all. So we will continue on the second learning outcome. Okay, we have discussed first learning outcome in the first part. So now we will discuss the second learning outcome for the second part of week 8. Okay, the second part is at the end of this topic, students should be able to evaluate indefinite integrals of algebraic functions. Okay, and the third LO will be covered in the part 3. Okay, many of the indefinite integrals are found by reversing derivative formula. Here is the list of basic integral formula for some standard functions. Okay, so we have the integrals, okay, and also the differentiation. So normally this, as I mentioned before, the table of differentiation and integration will be given during your test and your final exam. Okay, if we differentiate constant, so we will get 0. But if we integrate constant, okay, integrate constant, you just put kx plus c. Okay, for example, okay, integrate two. Okay, integrate 2, so you get 2x plus c. Okay, next, integrate x to the power of n. Okay, integrate x to the power of n, so you will get x to the power of n plus 1 over n plus 1 plus c. Okay, let's say we have example, integrate x to the power of 5 with respect to x. So what will you get? So you have x to the power of 5 plus 1 over 5 plus 1. And this one is plus c, or you can write as x to the power of 6 over 6 plus c. Okay, so this step is optional. Okay, you can write, or you just keep it and write as x to the power of 6 over 6 plus c. Okay, alright, if you have, for example, I give you another example, x to the power of negative 1. Okay, if you use the formula as this one, okay, so you'll get what? X to the power of negative 1 plus 1 over negative 1 plus 1 plus c. So negative 1 plus 1, you get what? 0, right? So you have x to the power of 0 over 0. So this cannot be happen because we cannot have the denominator as 0. Okay, so we have a special formula when we want to integrate x to the power of negative 1. So x to the power of negative 1 we can write as 1 over x also. So integrate 1 over x with respect to x, so you get log x. Okay, alright, so here are some the integrals. Okay, so integrate sine, you get negative cos. Integrate cos, you get sine x. Integrate secant squared x, you get tangent x. Integrate cosecant squared x, you get negative cot x. Integrate secant x tangent x, you get secant x. And integrate exponent x equal to exponent x. Okay, so maybe you can slowly memorize all the integration later. Okay, so let's look at example 1. Okay, so this is just a basic. So actually you have learned this before during your SPM, right? Do you still remember? Okay, alright. So let's start with A. Okay, evaluate the integral. We have integration of x cubed dx. Okay, so to solve this, okay, we use the formula just now. is you have x to the power of 4 over 4 plus c. So this is a very simple answer. Okay, right, let's move to B. So integrate square root of x. So square root x, okay, you rewrite as x to the power of 1 over 2 or x to the power of half. So by using the same formula, so you get what? X to the power of 1 over 2 plus 1. So you get 3 over 2 over 3 over 2 plus c. Okay, so next is you need to restructure your answer. So over 3 over 3 over 2, so you can write as 2 over 3 x to the power of 3 over 2 plus c. Okay, so example 2. Okay, evaluate the following integrals. So we have integration of dx over x cubed. So again here, okay, you can write as x to the power of negative 3, right? So because x to the power of 3 is the bottom, so you bring it as a numerator, so you get x to the power of negative 3. So solve by using the same formula, negative 3 plus 1, so you get negative 2 over negative 2. Okay, plus c. Right, we can write as negative 1 over 2x squared plus c. Okay, so next question, exponent x. So this is from table. If you still remember, so exponent x, integrate, you will get exponent x plus c. Okay, so next example. So evaluate integration of x to the power of 4 over 5. Okay, so we can write, or we can solve as x to the power of 4 over 5 plus 1. So you get what? Okay, 4 plus 5, you get 9. Sorry. So 9 over 5 over 9 over 5 plus c. So rearrange or restructure. So we get 5 over 9 x to the power of 9 over 5 plus c. Okay, so let's move to the second one. Okay, integrate 1 over secant x. So do you still remember what is secant? So secant is 1 over cos x dx. So actually you can write as integrate of cos x. So this is simple. So integrate cos x, you will get positive sin x plus c. Okay, okay, so now let's look at the theorem 2. Okay, basic properties of indefinite integrals. Okay, the first, the constant factor k can be taken out from an integral. That is, if you have integral k fx dx, so you can just bring k in front. Okay, and you just only need to multiply with the integration of fx. Okay, b, so the integral of a sum or difference equals the sum or difference of the integrals, which means that you can split this f plus g into two different integration. Okay, so let's look at some of the examples. Okay, example 4. Evaluate the following integrals. Okay, we have two terms there. Okay, you can split into two different integration, which I have just now, 3x squared dx plus integrate 8 dx and integrate 3x squared. So 3 you just maintain as 3 in front, so x squared integrate, you will get x cubed over 3. Okay, so for this one no need to put plus c for the first part. Okay, we just combine it, because constant plus constant you will get constant as well. Okay, and then the second part, integrate 8 with respect to x, so we get 8x. Okay, and now you need to put the constant plus constant. Okay, so simplify, so 3 and 3 you can cancel out, so the final answer will be x cubed plus 8x plus c. Okay, so let's move to second example. Okay, example 4b. So this one I don't want to split into two integrals, so I just integrate it. Okay, so integrate sine x, so I put 3 in front. Okay, integrate sine, you get what? You get negative cos x. Okay, and integrate 8 cos x, so you will get 8 sin x, and then plus c. So I just put negative in front, so I have negative 3 cos x plus 8 sin x plus c. Okay, so we look at the last example. Okay, so evaluate the following integral. So we have x to the power 4 plus 2x minus 6 dx. So this one you will get what? Okay, x to the power of 5 over 5 plus 2x squared over 2 minus 6x plus c. Okay, so simplify. So we get 1 over 5x to the power of 5 plus x squared minus 6x plus c. Okay, alright, and this is the last example. Okay, we have, if you look at question B, you have this form. Okay, so what you need to do is we rewrite as 3x squared plus 5x to the power of 1 over 4 minus 4x to the power of negative 3. Okay, it will be easier for you to integrate that. Okay, so 3x squared, integrate, you'll get 3x cubed over 3. Okay, plus 5x to the power of 1 over 4 plus 1, so you get 5 over 4 over 5 over 4 minus 4x to the power of negative 3, integrate, you get negative 3 plus 1, so you get negative 2. So this one will be negative 2 plus c. Okay, simplify. So this one, can you cancel out this? Okay, so you get this one 5 over 5, and then this one also can be cancelled out. So you will have the final answer as x cubed plus this over 4, you bring 4 as a numerator. Okay, 4x to the power of 5 over 4 plus, because negative negative, we get positive, plus 2x to the power of negative 2 plus c. So this is the final answer. Okay, so this is the example for learning outcomes number 2. Alright, so we meet again on third part. Okay, thank you.